So hello everyone, my name is Kamakana and Keshri. So today I will present my project, a movie recommendation system, right? The goal is of the project is suggest a movie that a user will like. So in this project, a user can browse trending movies or search movies by title and open a movie to see the details. You can see my screen. Yeah, when I come to the home section, yeah, you can see the movie. Okay, so I built this project in 3 parts, right? The first part is in backend API. The second part is in machine learning model, which is in data science layer. And the third part, of course, this UI. Okay, suppose that I'm searching the movie Batman. Now it goes to the API and it recommends the movie, right? So yeah, I also use TMDB, the movie database, for a live poster and a search and the movie details. Now, what is the problem statement, right? So many people like one movie, but they do not know that what to watch next. So in big platform often use rating for a recommendation. In my project, I use content-based method. That means if two movies having similar plot and if having similar genres and similar taglines as well, the system treats them as unfamiliar. So my system gives the two types of recommendation. Similarly, movies using TF-IDF and a cosine similarity. And second is same genre movies using TMDB API. Now, the project architecture is look like this. So the front end is of course based on app.py. Okay, so backend is this main.py and ML files in the pickle, and external services is TMDB API, where I just created all of these modules. Okay, so I have a data set as well. So for machine learning part, I use movie metadata set. So here you can see movies metadata.csv. This data set contains movie information such as title, overview, genres, tagline, and popularity and ratings, right? So this is my offline data set for training. For the live app, I use TMDB API, and my API key is stored in .env, right? And the TMDB API key, so it is, right? Okay. So let's get into the data science part. Okay, when I came into the data science part, the data science layer. So yeah, so I did all cleaning and training by movies.ipnb. You can see here. So what is my first I load the data. Second I just check the data and remove duplicates. So here are multiple duplicates present. So NaN. Okay, so I found the columns and I found the information about the data. Okay, to understand the data, I found the data and I got the shape. You are seeing the shape of the data, right? And I found the null values. So here's lots of null values. So I drop all null values and reset index. Okay, so yeah, I prepare the data and I just keep only useful content, that is title, overview, genres, and tagline, vote average, and popularity, right? Yeah. So step 4 is the handling the missing value, right? So removing rows without titles, okay, and fill empty overview and tagline with a blank text. So in step 5, I convert genres into the JSON format, text into the plain. Okay, so here you can find the genres is in the JSON format. Okay, and I want to convert into the plain text, so I use this. So I just, by using this, I converted this genres to the this text format, right? Now step 6, I of course I create a new columns and the tags. Yeah, you can see that I create a new columns and the tags. Okay, now again I just see here I have the polished data, right? Okay, now my machine learning model, after cleaning, I built context based recommendation. Okay, so I use TF-IDF. So what is TF-IDF means? So TF-IDF means it's a team frequency inverse document. So it converts usually movie text into the numbers, right? If I am saying that my name is Kamakya Narayan Keshri, so if I want to convert this into some embeddings, so how can we convert my full English to the embeddings into the sum of the numbers? So I convert them into the embeddings, like I want to convert into the numbers, so I use TF-IDF. Now I am using here TF-IDF. So here it converts, so simple, it converts movie text into the numbers, right? So team frequency means how often a word appears in a one movie. Okay, and inverse document frequency means how rare the word is across all the movie. Now important and rare words get higher scores and common words get lower score. So suppose that my name is Kamakya Narayan Keshri. It is a sentence. My name is Kamakya Narayan Keshri. I usually go to the school daily. So usually is a less prior word, right? So the value of usually is quite lesser, and school values, the value of school being higher. So yeah, so important and the rare word gets a higher value. That means, okay, so I used mac feature as in 50,000. Yeah, you can see that. And n-gram says as in 1,2. And yeah, So I use also a cosine similarity as well, right? So in cosine similarity, right, what is the cosine similarity measures how the close of the two movies vectors are. Suppose that my name is Kamakhya Narayan Keshri, and this is the first sentence, and second sentence is Kamakhya. So Kamakhya Narayan is the first sentence and Kamakhya is the second sentence, right? So the I made a graph in which I plot first Kamakhya Narayan and the Kamakhya. So Kamakhya is how much relatable to Narayan. If Kamakhya is relatable to Narayan, then the values comes to be the 1 and cos theta value is equal to 45 degree. Okay. So this having the formula how we calculate this cosine similarity. Okay. So score nearer 1 is a very similar and score nearer 0 is a not similar. So if we enter in a movie like Avatar, the system finds movies similar to the content and save model to the file. Now we have we did all of things. Okay, so we make an pickle file in which I use indices.pickle, tfidf.pickle, and tfidf underscores matrices.pickle. So I usually made this file to make my model. Okay, now let's come into the backend part. The backend is built into the fast API in main.py. Okay, so whenever the server start, it loads the TMDB API, loads the pickle file, and builds a title to index map. Main API endpoints is like /health checks if the server is working, /home shows trending and popular movies, TMDB search. Okay, let's take me over there. Okay, so TMDB search returns a movie details, recommend genres, return the same genres. Okay, /movie /search returns a details if plus tfidf recommendation and general recommendations, right? Okay, see, okay, now let's come into the front end UI. So it is in the app.py. So here I just open the UI part. Here you can see the home section shows a movies category like trending and popular. It allows keyword to the search and details part as well. Suppose that I am going to search a Batman or I am going to search Spy Kids. I don't know. Okay, so I'm sorry, Avenger. Okay, now I got some recommendation, right? And when I go to the click to the Civil War or Captain America, the first Avenger. So here we can see the overview part and as well, like, of course, yeah. So end-to-end working flow is like that. Here is a full example, like you can see all of things. So user is typing the Avengers. So Streamlit calls TMDB search and backend gets matching movies from TMDB, and users select one movie and opens it. Streamlit loads the details from the movie ID and then it calls to the movie search. Then backend finds the movie and yeah, it shows into the UI part. Okay, suppose that Batman, right? So yeah, is a Batman. Okay, so yeah, it finds the similar movies and yeah, front end shows all the report card into the poster format, right? What a tech stack I use. I just showcase all of my tech stack. I used Python, pandas, and NumPy NLTK for our text cleaning, scikit-learn for tfidf and cosine similarity, fast API for backend, Streamlit for frontend, TMDB API for a live movie data. Okay, and render for API development. And usually I didn't deploy this project because I just completed my free tier of render. Okay, so yeah, no, it's a couple of things that I have to do. Okay, so yeah, the advantage is of course works without user rating history. Of course, like when you rate some movie to, then it recommends that movie. But if you come here, I know this is a small project, but if you come here, like yeah, you have a fast recommendation using saved tfidf matrices like general fallback. It contains a similarity false, right? So yeah, it's all things. So to conclude, I build a complete movie recommendation system. I clean movie metadata, created a tags features, converted text into TVF IDF vectors, and used cosine similarities to find similar movies. I served with the model with fast API, adding live data of TMDB data, and build a Streamlit UI for browsing, searching, and recommendation. So yeah, thank you for to watch my whole video and hope you like my project. तब तक के लिए शुक्रिया. तब तक मिलते हैं next project में और इसी तरह बनिए. I am going to connect with this Mon app. I'll just go to the Mon app. How will just connect this API to the Mon app and how I'll gonna make these things and AI plus Mon tech, right? So yeah, stay tuned and most of the lecture are coming. Bye bye.